Students, today we are going to solve a question, and it's a beautiful question from particle physics. And that question is given: a proton, sorry, a pi zero meson, it is producing with different momentum. It is producing with different momentum, okay, and it is immediately it will have momentum. Let us take that momentum is p. It is immediately decaying to two photon. And angle between them is given. Angle between them is theta. Okay. So pi zero meson is producing with different momentum and it's immediately decaying to two photon. And angle between them is given, that is theta. Okay. So you have to show that plot. You have to show, or you have to find out the plot between angle theta versus momentum of incident particle or momentum of pi zero meson. It's a very simple question. I mean, just you have to apply the trick. Okay. So as we know, when a particle, let us take pi zero itself, is at rest. Rest means it will have momentum zero. Then two photons will be emitted exactly in the opposite direction in order to conserve the linear momentum, because for any nuclear interaction or any particle decay, the linear momentum should be conserved. So in order to maintain or in order to preserve that linear momentum zero, they should move in opposite direction. Now the angle between them is how much? That will be 180 degree, or I can say pi. Okay. The photon, the pi zero particle having linear momentum will emit two photon, and their angle will be theta will be how much here? Theta will be 180. Now, if the momentum of this particle is non-zero, let us take that fellow pi zero. He is having some momentum non-zero. Then angle between them is no longer be pi, rather it will be smaller angle. So theta will be less than pi. When p is non-zero, then theta will no longer be pi, but it will be smaller than pi. Okay. So this angle is theta. This angle is theta. It is given. So angle between horizontal line and first photon, that will be theta by 2, and this angle will be theta by 2. So total theta by 2 plus theta by 2, that will be theta, and this is your second photon. So two photon 1 and photon 2 are emitted at an angle of theta. So angle between horizontal line and emitted photon, that will be theta by 2, and for second again it will be theta by 2. And let us take this is your x axis. So incident particle or pi zero is having momentum p. So in order to preserve that x component of momentum, in order to preserve the x component of momentum, or x component of momentum should be conserved. So I can write, so incident particle, I have assumed it is at x direction. So initial momentum p should be balanced with, let us take that momentum of this gamma is p dash, this photon is p dash, and this photon is p dash. Okay. So component of momentum, x component of momentum of this photon will be p dash cosine theta by 2, and for this also it will be p dash cosine theta by 2. They have momentum p dash p dash. So angle between horizontal line and their direction of flight, that is theta by 2. So obviously the x component for both photons will be cosine theta by 2. So and they are in the same direction. So if I sum them, so x component of momentum of the product will be twice p dash cosine theta by 2. Okay. So what I can say, that cosine theta by 2 proportional to the momentum of incident y0 particle. So when p is 0, cosine theta by 2 is equals to 0. When p is 0, cosine theta by 2 equals to 0. It means what? Cosine theta by 2 equals to cosine pi by 2. It means theta will be pi, and that we know actually. But if you increase p, what will happen? From this relation, I can say there will be decrement of theta. Okay. If you increase the value of p, there will be decrement of theta. So this relation itself is saying there's an inverse relation between momentum and direction of flight of two photons. So if I plot it, the momentum along this direction, the momentum of incident pi0 particle, and this is the angle between two photons. So that that plot will be like this. So at p equals to 0, this will be pi. Okay. So this will be the correct. Okay. Thank you.